Friends, take a look at this interesting exercise we have here. We need to find the shaded area of the figure. Alright, notice that we have a square and a circle that is tangent to one side of the square, right in the middle of the square. Alright, we have some lines here that divide the square into 4 small squares. Let's call the side of the large square 2x. Therefore, the side of the small square from here to here will be x. And from here to down here, well, also x, right? So we're going to label all the sides of the square. Here we have x, x. X here, x there, and x on this side. Very well. We have now labeled the sides of this square. Now let's call r the radius of this circle that is empty here. So from here to here, it will be called lowercase r. Let's draw a line from this point to this point here in this way. And this blue line will also be the radius of the circle because it goes from the center to its perimeter. So it is also r. Very well. Now check that this is a side of the small square. So it is x. If we take away this piece that measures 3 from this side, we have this side of this right triangle that forms here. Notice, then this side will be x minus this piece which is 3. Now, this part here, which is the other side of the right triangle, will be from here to there is x. We already said it, right? So if we take away this little piece, which is r, we get that this side is x minus x. Phenomenal. Then we can use the very powerful Pythagorean theorem. Because we have everything labeled, we are going to use the Pythagorean theorem in this right triangle here. The hypotenuse squared is equal to one leg squared plus the other leg squared. Very well. Who is the hypotenuse? Well, it's this blue line, which is r. IRA squared equals the side AR, which can be either of these two sides. Let's say it is this one here. Then we have x minus r squared plus the other side logically is this one here, x minus 3, minus 3 also squared. We are going to expand these two binomials. Here we have r squared, here we have the first term squared, which is x squared, minus the double product, the first by the second, 2 times x times r. And plus the second term squared would be r squared. Then we have this plus, and then we develop this binomial, first term squared, x squared minus double, the product of the first by the second 6. Let's write it down at once, and plus the second term squared, 3 squared gives us 9. Very well, and notice here this r squared cancels out with this r squared. On the left side we get 0, and on the right side, here I have x squared plus x squared, 2x squared. Then we have this term here minus 2xr, then we have here minus 6x. Very well. And finally, we have this 9 here. And at this point, you might be saying, what is this crazy person doing? No, but there is a way to solve it. Notice the side of the square is 2x, and this side must be identical everywhere, right? So this line that divides the square into 2 equal parts must also measure the same. Therefore, if this line measures 2x, we can put 2x here, which has to be equal to the sum of these pieces. From here to here is r, from here to here is also r, and from here to here is 4. Therefore, the sum of all this is 2r plus 4. Let's put it here. Everything is divisible by 2. Let's divide it by 2, by 2, and by 2. Simplifying here, we have that x is equal. We simplify here. We are left with r and 4 over 2. Well, it's 2. Fascinating. We already have here the value of x as a function of r that we can replace here. Let's do it. 0 is equal to 2 times x, but x is equal to this here. Let's put it r plus 2 and this squared minus 2 times x and r. We are going to switch the places of x and r. Notice first we will put r and then x, just because it's convenient, not to make it look better. So we have 2 times r and x, but x equals this here r plus 2. Very well, then we have minus 6 times x, but x equals this. Once again, r plus 2. And finally, we have this 9. Here, let's expand this binomial squared. We have on the left side 0. On the right side, we have 2 multiplied by this here, r. First term squared would be r squared plus double the product, the first by the second 4r. And plus the second term squared would be 4. Very well, We apply the distributive property here. Minus 2r times r gives us minus 2r squared. Then minus 2r times 2 gives us minus 4r. Here we do the same. Tatate namape tarimpase nanuke maninote minus 6 times r minus 6r, and finally minus 6 times 2 gives us minus 12. And here we have positive 9. Excellent. Let's apply the distributive property here as well. Notice 2 times r squared, 2r squared. At the 2 times 4r gives us 8r. Very well. And finally 2 times 4 gives us 8. Very well. The rest stays the same. Minus 2r squared, minus 4r, minus 6r, minus 12, and plus 9. What kasi sinta na very well. And notice that 2r squared and minus 2r squared cancel out here. Goodbye r squared. And over here, we're left with only r. 8r positive. Over here, we have minus 4 and minus 6r, which gives us minus 10r. Minus 10r plus 8r gives us minus 2r. Very well. And over here, we have 8r, then we have 12 and 9r. 8 positive and 9 positive give us 17, and minus 12 give us 5. Very good. We are going to move this negative 12r to the left side. We have 12r, and on the right side we have this 5. And finally we divide by these 2, and we have obtained, ladies and gentlemen, that the radius of the circle is 5,000. Fascinating. Now what we are going to do is find the area of the square. To find the area of the square, first we need to find the side. So the side of the square is 2x. We already knew that 2x was equal to 2r plus 4 from what we have here. So 2r plus 4. Very well. Let's replace r, and we have 2x equal to 2 times r, but r is 5 halves. Let's replace, and plus 4 simplifying. Here we get 5 plus 4, which gives us 9. That is to say, ladies and gentlemen, 2x is going to be equal to 9. The side of the square is 9. Therefore, the area of the square will be equal, but which square? No, the area of the square will be equal to side by side. That is 9 by 9, which gives us 81 square units is the area of the square. Let's put here that the shaded area is equal to the area of the square. Notice the area of the square minus the area of the circle. By here minus the area of the circle, the area of the square, we already know is 81 square units. Let's just write 81. And the area of the circle, well, it's pi times radius squared. The radius we already know is 5 halves. Let's replace it then. 5 halves and all this squared. Here we get by Newton's methods that 81 minus 5 squared, which is 25 pi, and 2 squared gives us 4. And we have that the shaded area, ladies and gentlemen, is 81 minus 25 pi squared. Quarter square units, isn't it? Fascinating. Let me know in the comments if you liked the video, and don't forget to subscribe, give it a like and comment on it so you don't miss the upcoming exercises. We will see each other another time. Bye!